former student of Department of Statistics. She's also a data analyst with proficiency in R programming, Power BI, Excel, and also SPSS, and also other W, and also other data analysis softwares. She'll be taking us on descriptive statistics with SPSS. And right now, I'll pass the mic to Oluchi. Oluchi, please carry us along.
Okay, thank you for having me here. Good evening, everyone. Please let's
Imam.
respond. Good evening, everyone.
Good evening.
Good
Good
evening.
evening. Good
Okay,
evening.
thank you all. Okay, so today, Oluchi Peter, as you said, I'll be taking us on the journey of descriptive statistics, using SPSS. Now, before I start, I want to appreciate everyone that took out their time to actually make sure that they are online for this webinar. It is not a waste to attend this webinar. It is never a waste. I'm very sure that today we are going to learn one or two things, and I'm sure that if for those of us that were online today, if you've been attending the previous classes, I'm very sure you learned one or two things. Okay, so I want to welcome every one of us. So before I start fully from descriptive statistics, let me share my screen. Let me share my screen. So before I start, I'll be explaining. I'll be taking us back to data entry in SPSS, because the last time it was done, it wasn't actually, because of time and network glitches, we were not able to actually do a lot of things. Okay, can you all see my screen?
Yes,
You
I can
can.
see your
You can.
screen.
Okay, thank God. Okay, so before that, I would like to explain some little things before we kick off to the descriptive statistics. So now this is my SPSS. This is the SPSS form here. So when you go to file, I want to create a new file. So I'll go to data. Now this, please, I don't know. There's someone that is his mic is disturbing me here. Please, let's check if our mics are actually muted, are off. I mean, our microphones are off, please. Thank you. Okay, now this is the SPSS. This is our SPSS font here. Now, before we start anything, I would like to explain some little things. So from here, we have data view and we have the variable view. Now, under the data view is just like a little snippet of our data. It shows us a little part of our data, like the full data itself. It shows us the full data itself, sorry. Then when you come to the variable view gives us details about our data. Now, okay, let me take us back to a data set that I've called in already. Now, this is the data view. I'm at the data view here. Now, we can see the data set itself. You can see that from here, I have the group. I have AGS, marriage status, occupation, education, menstruational pain, and all of that. These are data sets on women pregnancy and all of that. So now, when we go to variable view, now you see the name here. You see the name. This name is just the title you are giving to the header of that column. Okay, let's take for example this number one. The first one we're having is group. When you come to your data view, you will see group here. Are we getting it? Please let's respond. Are we getting it? Hello,
Yes,
can you all hear me? Okay,
yes, I
okay.
can
Thank you.
hear you,
I
ma.
just want us to be going along. I don't want to be going back and front. So now, the next one we're having here is age years. That's the ages of the women. When you come to your variable view, you will see it as the second name here. So that's tell us that the name of these names that are here, everything that is here, they are just representation of what we use to represent our columns on the data view. Then we have the type. Now this type shows the type of your data set. Now under this group, we have it. When you go to your data view, you will see you have B, letter B, A, letter B, and A. When you go to age and years, you see that you have 27, 20, 21. Now let's go back to our variable view. Now the group is in string. Why? Because string from what we know, yes, string are like alphabets. They are like alphabets, while the AGS are numeric. So this type signifies the representation of your data set. Are they string, are they numeric, or are they even decimal as well? That's it. So you can even go ahead and check for others too. We have numeric, we have comma, we even have dates, we have dollar, and we have custom currency, and like that. That's it. So under the width shows the length of that particular data. Now under group, remember we had B, A. That tells us that it is only one, like B and A. But under age, I can have as long as the width to be 12. That's what it's saying. Then the decimal is, do we have any data that is, do we have any column that has decimal in it? If it is no, it will show zero. Now let's check this one that is 2 here. This one that is 2, that's HTM. Let's go back to our data view and let's see it there. Now you will see that HTM, you can see that we have 2, it is in 2 decimal places. That is why it is 2 at that decimal point at the variable view. Are we getting it? So for label now, label is like a little description of what your name is. That's the name, this name that here, a little description. Now remember, I want to take us back again to the conditions of giving this of representing your column on SPSS. I want us to know that if, let's say for example, I don't want group to be there, and I put GROUP, which is group, and I put space there, and I'm writing something else, and I press on enter, it will not, you see that it is an illegal character. That's to tell us that.
Button.
Sorry, are you talking to me? I don't think that's me. So let's move on. So now you can see that the group is it can be it's not acceptable to use to save your name, yes, in the data view as giving it space. It is not acceptable. That's for that. So we have under the label, we have AGS. Now I would have also signified using underscore. It is still acceptable. Can we all see it? It is still acceptable. And if I like, I'll still remove it. And if I put space and I click on enter, it won't take it. That is what SPSS is doing. So now let's go back, let's change this one. So we have it as AGS. So now this label is not telling us that what does that name means. What does it mean? So this one now is telling us AGS, the name is in AGS, yes. So the label is now saying age in years. That's what it means, age in years. Now we have M status. Normally if I'm telling you something is in M status, you won't be able to understand, but because of label is not, we are not giving it a description, we are giving that name a description. That's why we have marriage status. Then we also have another one. We have maybe like, okay, let's take for example 21, the line 21, we have pain left. It doesn't mean anything, but when I come to my label, I can see I have pain level. That's what label is all about. Then we also have values. Then values is more or less like you representing your data. Let me go back, let me click on it again. So when you come here now, you click on these 3 dots, you have this. Now I can group my age to be, maybe I want this to be maybe age 12 to maybe 13. Sorry, hold on. Add. Okay. So I'm saying maybe age 12 should be 1. Are we getting it? I can say age 12 to be 1. I can say age 13 to be 2. That is what value label is all about. Then the missing values, the missing column is, it talks about the missing data, the missing columns you might be having in your data set. Then this column is not actually necessary like that. Then the one I want to even go to again is the measure. Measure is very, very, very important. You have to understand the different kinds of measure that we have in general in statistics before you can say, okay, I want to do with anything called analysis. You have to understand it. Now when we are talking about nominal, I would like to take us back to continuous and categorical variables. So continuous variables are usually numbers. They are such as height, temperature, such as height, temperature. But and another thing again about continuous is that you can do arithmetic or continuous variables with it. Then we have the categorical. Then the categorical are things that can be classified and they are usually written as text. Now, categorical in the sense that the gender that we have gender, we can categorize gender to be male or to be female. We can classify classes, maybe we can classify departments as well, statistics, mathematics, physics. Now, each people people have to fall into these different groups of categories that we've created. So that's what categorical is all about. Now it is not another thing I want to mention again is that nominal and ordinal scale, they are considered as categorical. They are considered as categorical variable, in the sense that nominal are things that are natural, they are naturally ordered. Take for example, let's say let me think of an example. Okay, we have gender. Yes, we have gender, we have the male and the female. But when I have, let's say, take for example, I have my age. Age is continuous, they are numerical. But if I wish or if I like, I can categorize my age, because maybe I want it to be some, I want my analysis to be well described. I can just say, okay, let my age group, maybe ages of between 12 to 30 should be group 1. Ages between 31 to 40, group 2. Now that one is ordinal. I just add, I just want it to be ordered. That's what it is. Then the nominal comes in form of, it is natural. Take for example again, let's take for example again, maybe we are talking about I don't know, I can't sorry, I can't even remember again. But just let's just stick to that gender one again. As we go on, we'll get more idea about it. So another thing I would like to mention is that there are some things that they can either be continuous or categorical. Take for example, we have age. Age is a number, so by default it is continuous. Just as I said earlier on, if I like, I can change this to be a categorical variable. That's for age. I can also do for time. Time normally, like time maybe 60 minutes, 30 minutes, it is something that it is continuous, a continuous variable. But if I wish, so I can just change it to a categorical variable, in the sense that, okay, I can have maybe 2001, 2003, 2004, and even months as well. So that's for the previous part. So now let's go to descriptive statistics itself. Sorry, can we all hear me? I need responses, please.
Yes.
Thank you. Okay, so let's go
Yes,
to
yes,
descriptive
yes. Well done.
statistics.
Good job.
Thank you, sir. Thank you, sir. So let's do the introduction to descriptive statistics now. So in statistics, we have some methods and we have some tools. Let me not say tools. We have some methods. Let's stick to methods. So we have some methods that we can use to describe our data. Now we have descriptive. When it's just like when we're in secondary school, where they say when we are teacher, our English teacher will tell us to write a descriptive essay of how you spent your holiday. Now, if I don't know if anyone can remember, but let me just take us back to those days. Now, when you want to write those descriptive, how do you start from? So I started my holiday on this so date. I traveled to this. I traveled to this location. So I fell down. I ate chicken. I did this one. You are describing. That's what it is. So it's the same thing as well in statistics. When we have a data set, that's our data sheet. You need to have a descriptive idea of what your data looks like. Are we getting it? So you need to have a better understanding of, okay, is my data set, how many observations do I have in my data set? What is the mean of my data set? Like, okay, for this column, for the column of ages, what is the highest number? That's mode. What is the number that, okay, among all the observation, it appears the most? That is our mode. Okay, you can even ask again, what is the variation, what is the standard deviation, like that. So all this method, they describe our data set. So summarize, describe, and analyze the key characteristics of data collection. A set of method and techniques known as descriptive statistics is used. It provides a quantitative summary of the data and helps in understanding the central tendencies, variability, and distribution of the data. Now, descriptive statistics can be applied to both numerical, categorical data. So that's like continuous and categorical data, and is used to facilitate the interpretation of data, draw inferences, and make decisions as well. So, all in all, descriptive statistics, what it helps us to do is it helps us to interpret our data and have a better understanding of our data. Someone can just ask you that, okay, in your department or in your class or whatsoever, that what is the average number of students in your class? Like, it's something like, okay, let's say for example, maybe our LAs now, our LAs are in charge of our level advisors, they are in charge of our documents. So maybe HOD can just ask him that, what is the average number of students in your, or the average age of students in your department, and he's looking, no, best thing he can do is just maybe go to his computer fast, run a descriptive statistics on the number of students he has on his computer, and he'll just get the mean. That's all. So this it gives us this better understanding of what our data is like. So now let's go to the types of descriptive statistics. So we have the first one to be measures of central tendency, which describes the center of a data set or the points around the data tend to cluster. Now, the three most common measures of central tendency are the mean, median, and mode. I'm very sure we know this, but I will still explain. I'll just give a little and a brief explanation on it. So just like I said earlier on, when I talked about LA and the HOD, where you asked him what is the average age of students in your own level. Now, mean, that's mean. Mean can also be referred to as average. So mean is just like the sum of all your observations for maybe for like that column of age, then dividing it by the number of observations that you have. So that gives us the average age that is in that particular data set. Then we have the median. The median is the middle value in a data set when the data are arranged in order. It is commonly used when the data are not normally distributed or when there are outliers that might skew the results. So in this sense, we have some things, some things that are called outliers. Now, outliers are like, maybe take for example, in our data set or in a particular class, we are having the ages of 16, 17, 18, 19, 20 to maybe 29. Then the next one you now see for an undergraduate, you're not seeing 50, 60. That's an outlier because it is far from the main data set. That is what outlier is. So when the data set is being arranged in order, you can be able to get the middle value of your data set. Then we also have the mode. The mode is the value that occurs most frequently in a data set. I can have the column of age, and I want to know what is that particular age that is common in that level or department. Now it can be 36, it can be anything, but I just want you to understand that if it's, let's say for example, we run our analysis and we are seeing that the mode is 36. That is to tell you that the number of observations or the number of students that we are having in a particular level, 36 is the highest number. That's many people fall into or fall under that group of 36. So it's not as if it's only the age of 36 that we have. We have several of them, but the highest number that has more people under it is the age of 36. So that's what measures of central tendency is. So the next one is measures of variability. It describes the spread or dispersion of data. The two most common measures of variability are the range and the standard deviation. Now, the range is calculated by subtracting the minimum value from the maximum value in a data set. It is easy to calculate, but it can be misleading if there are outliers. Now, take for example, like the example I gave earlier on, where we have from ages of 16 to maybe 29 for an undergraduate level, maybe like 400 level. That's the age we are in. You're not seeing like 50 or 60. Now remember we said range is the subtraction of what, the minimum from the maximum. Now in that sense, if that's how the level is, and we're having 60 to be the highest, and we're having maybe 16 or maybe 20 to be the lowest, that they are saying 60 minus 20, which is 40. That is not correct at all, because 60 is an outlier, 50 is an outlier. So it has misled us on what is the real range of our data set. Now we also have the standard deviation. which measures the spread of the data from the mean. A high standard deviation indicates that the data is more spread out, while a lower one indicates that the data is tightly clustered around the mean. If you're having a mean of 5.6 and you're having a standard deviation of maybe 8.0, that has to tell us that the dispersion of that particular data is very far from the mean, and which might not be useful to us when we are running our analysis. Then we also have the variance, which is just the square of the standard deviation. Then we have quartiles, which divides the data set into four equal parts. The first quartile is Q1, that's which is under 25% of data fall. Then the second quartile, which is Q2, which is the median. Then the third quartile is the value below which 75% of data fall. Then the interquartile is the range of values between the first and third quartiles. It is a measure of the spread of the middle 50% of the data. Then the next one we have is measures of distribution, which are considered as a type of descriptive statistics. Now, the measures of distribution describe the way data is distributed or spread out in a data, and they are commonly used to provide information about the shape, symmetry, and outliers in a distribution. So this one is mostly important when we are running with something like normal distribution, where we have to check if this the kurtosis of a data set is actually normal. So we have the first one to be skewness, which is a measure of asymmetry of a distribution. A perfectly symmetrical distribution has a skewness of 0. Why the I don't want to take us through all this long journey because it's not really necessary when we are running our analysis, our basic analysis for descriptive. So let's just move on to the slide 6. So let's go to graphical representation in SPSS. So we have several graphical representation in SPSS, but the most common one that we use for running our analysis are the one that we'll be discussing here. So the first one that we have is histogram. So histogram are used to display the distribution of a continuous variable. I've explained what a continuous variable is. This involves the variables that are numeric, they are in numbers. So now let's go on. The x-axis represents the variable values and the y-axis represents the frequency of those values. Now the bars of the distribution of the histogram is drawn adjacent to each other to show the frequency of values in each range of b. Then we also have the box plots. Okay, before I go to the box plot, let me give us more let me give us a a specific assumption of histogram. Before you have your histogram plot, make sure that the variable you are putting into that histogram plot, it should be a continuous variable. If you are using a categorical variable, you will never get your answer. Yes, you will never get your answer. The variable must be continuous, or else you will not you in fact what you'll be seeing, I don't even think it will run safe. It will not even run at all. So the next one we have is box plots. So the box plots, also known as the box and whisker plots, are used to display the distribution of a continuous variable. The same for histogram as well. Box plots also makes use of continuous variable. Now, for the box plot, it splits a continuous variable like age, where we have maybe a particular set of we have age. Then it splits the data, that column of age. Then the box plot extends from the lower quartile to the upper quartile. While before after this, we'll be going to the SPS, we'll be going to our SPSS to actually see more things on it and to have a better understanding. So the next one we have is scatter plots. The scatter plots are used to display the relationship between two continuous variables. We make use of scatter plots mostly when we are dealing with regression. When we want to see if there's a relationship between one variable and the other variable. Then we can also make use of then another thing again in scatter plots is that when you are the interpretation of scatter plots is the idea of correlation, and we use correlation in regression, just as I said, to have a better understanding of the relationship that we have. So now, then what is correlation? For those of us that don't know, correlation is a measure of how well you can draw a straight line from the point. So if your straight line is going upward, that means there's a positive correlation. But if it is going downward, that means that means that we have that means that we have that means that we have a negative correlation. So that's for the scatter plots. Then we also have the line plots. The line, okay, we have the bar charts. Now the bar charts are used to display the distribution of a categorical variable. Now for scatter plots, histogram and box plots, we make use of continuous variable. But when it comes to bar charts and pie charts, we make use of categorical variables. Now, for the bar charts are used to display the distribution of a categorical variable. The x-axis represents the categories, and the y-axis represents the frequency or proportion of observation in each category. Now, I don't want us to use age again. Let's use gender now. Let's say we're having, gender is a categorical variable. That's, we have the male and we have the female. Now I don't want to know, okay, in my own level, 400 level, I want to know the number of people that are male, or the number of people that are female. Are we getting it? So that's when you make use of bar charts. Now, so for the x-axis, it will contain the categories, that's male and female. Then the y-axis represents the frequency. So the frequency gives us the number of counts that we have under each categories. I hope you get that. So we have the pie chart. The pie charts, they are used to display the proportion of a categorical variable. Take for example, maybe you want to know the percentage now of male and female. You can use pie charts to visualize that. So we have the line graph. The line graphs are used to display the trend of a variable over time or another continuous variable. The x-axis represents time or another continuous variable, and the y-axis represents the value of the variable being measured. Now, each data point is connected by a line. Emphasis on each data point is connected by a line, which can show trends, cycles, or patterns over time. Now, previously we talked about scatter plots, but now, if I don't know if you can remember, I mentioned earlier on that if the straight line is upward, now if the straight line is downward, now where is that line coming from? That's when line graph comes in, or line plots. That's when it comes in. So you applying line graph to your scatter plot, you'll be able to see, you'll be able to understand, okay, is the variables that I'm having, the two variables I'm having, is there any positive relationship between them? That's if it goes up. Is there any negative relationship between them if it comes down? So all these things, all these little points, they really matter. Because if you're applying a categorical variable on your scatter plots, you will not see anything. If you apply continuous on histogram, you will never see anything. So all these things, you have to understand them first before you say, okay, I'm ready to run my analysis. You have to have a better understanding of how your data looks like. The variable that you have, are they continuous or are they categorical? Then okay, if it is continuous, okay, I can make use of scatter plots, I can make use of box plots, I can make use of histogram. What if it is categorical? I can make use of pie charts. Pie chart, okay, I want to see the percentage of people that I have under each categories. I can make use of pie charts. And if I want to see the frequency, that's the count of people I'm having under each category, I can now make use of my bar chart. So all these little things matter. Then another thing on that line graph I want us to know is that a line plot should be used when you have two continuous variable. One, two, you want to answer questions about their relationship. Is it positive correlation or is it negative correlation? And usually the most common case for that of y-axis represents date or time. But later on, subsequent class, we're talking about time series. So I want us to stay tuned to that time, please. That'll be the last class on SPSS. So I want us to have idea about it. So we use line plots very well when we are doing our time series analysis, because we want to see, okay, is the line graph, the line for that our particular data, is it something that is flowing, or is it something that is seasonal? The variability, are we having outlier? A lot of things. I pray that you guys will be able to witness that day in Jesus' name. Amen. So let's go on. So we have CROSSTAB in SPSS. So this crosstab option in SPSS is used when you want to examine the relationship between two categorical variables in your data. Now, specifically, it allows you to create a table that shows the frequencies and percentage of observation for each combination of the two variables. Now, crosstab can also be referred to as chi-square, yes. So now, when you're dealing with chi-square, the chi-square table is always like we're having the number of male, we're having number of female. Maybe we're having two categorical variables. Take for example, we have male, we have female. Then we now have maybe like height. So we now classified our height. We ordered our height to be maybe small, tall, as small, medium. Abi, how do I put it? Okay, let's use medium and large. Now, what's the number of people the number of male that are small? What's the number of male that are large or they have high number of height? What's the number of female that are they have small height? So that's what crosstab is all about. It gives us the knowledge of relationship between two categorical variables. Remember that when we are talking about scatter plots and line plots, we want to know the relationship between two continuous variables. Now, we want to know the relationship between two categorical variables. That is when we use the crosstab in SPSS. So the crosstab helps us to understand and investigate differences between groups. So if you have a categorical variable that divides your sample into two or more groups, you can use the crosstab option to examine differences between the groups on another categorical variable. They also have testing for independence. If you want to test whether two categorical variables are independent or whether there's a relationship between them, you can use the crosstab option to create a contingency table and perform a chi-square test. So this is when the chi-square test comes into play. Now, to obtain the crosstab of two categorical variables, we could obtain this from the descriptive option under the analyze menu. We are still going into that. So another thing again is overall the crosstab option in SPSS is useful for exploring the relationship between two categorical variables and identifying patterns or differences in the data. I said that earlier on. So now let's go to the main descriptive statistics. Now, so we'll be taking the steps one after the other. We're taking the steps one after the other. So now let's go. The first one is open SPSS software and click on open data to import your data set from the file menu. Now, open your SPSS. I've opened my own before, so you can open your own wherever you are. So let me close some unnecessary files. No, let me close it. Okay, now let me close this one as well. Okay, now let me take us through data entry. How did I manage to bring this data set into my SPSS? So initially when you open your SPSS, when you load the software, now you go to your file. Please let's follow. In fact, wait first, let me hear our responses whether we are listening. Can we all hear me? I want responses.
Yes, ma'am.
Can we all, are we getting
Yes, we
me?
can hear you.
Thank you, bosses
I
and
can hear you.
everybody. Thank you, everybody. So let's go back. Okay, so now you go to file, new. I want
We
to
can hear you.
open. So okay. Thank you. So we have file. You go to file. The next option you will see would be new. So this new. Sorry, let me go back again. This new. So we have data. So that means I want to open a new data. Then we have the syntax, then we have output, then we have the script. So now for me, I'm going for data. I want to open a new template for my data. So let's open it. So we have it here. So this is
Hello.
but I don't have my data set here. That we have. Sorry, please, can we all hear me? Hello?
Yes, I can hear you. I can hear you.
Sorry, please. Thank you. So let's go back to what we could. SPSS file that we're having. So now I want, because I'm importing an Excel file. So I choose Excel. I'll be choosing Excel. Now you see that it's changed the number of the variables I'm having, the data sets that I'm having. Now we have the Excel extension XLXX, like that. So now me, I'll be opening the wax raw data. The wax raw data. Now I'll not take open. I'll click on open. So you press OK. Now it is loaded. Do we see it now? So it is loaded now. Now the next thing to do is, okay, we've opened our data already. So let's go back to our slide. Now, once the data set is loaded, click on the analyze menu. Click on the analyze menu in the top toolbar and select descriptive statistics. So now let's go. Let's go to our this. Let me close all this one. Sorry. I don't want any unnecessary. Let's close this one out as well. No. So now, so we have our data view and we have the variable view. So like I said earlier on, now let's start analyzing. So we want to analyze. So we said once data set is loaded, click on the analyze menu in the top toolbar and select descriptive statistics. So this is our data sheet here. Now you click on analyze. So we have analyze here. It gives us a drop down. So we have descriptive statistics. Now a lot of things under descriptive statistics, but the one we'll be focusing on is frequencies, descriptives, and CROSSTAB. Then also a little of Explorer as well, but the rest, it doesn't really, it's actually not necessary when you are doing your project analysis. So the first thing we have here is frequencies. Now for the frequencies, frequency deals with continuous variable. So you have to know, okay, my group, it is something like the variable type is is in string, where we have letter B and letter A. Now we have our age. Let's take our age into here. So which other one is, so we have parity. Yes, parity is it continuous? No, it's not continuous. So we have height, then we also have weight. We also have weight. So we take it into the variables. Oh, this one didn't go. So that's that. So now let's check our statistics button here. What do we have? We have quartiles, we have percentile. So what do we need from this? What do we need from here? We can choose our mean, we can choose median, we want to see the mode. We don't need sum, it's not actually necessary. We can take our range, we can take standard deviation, we can take minimum, we can click on maximum, and we can click on variance as well. Skewness and kurtosis, let's just pick it so we'll see what the results will be. So you click on continue. Then what charts do we need? Let me go back to that. So after clicking on the statistics, the ones you need, you click on continue. Then we go to charts. Now, what charts do we need? Maybe since it is continuous, so let's pick our histogram. Abi, let's pick histogram. Now let's say for example we choose bar charts. Now you see that when you click on bar charts, now frequencies and percentages will come out. And okay, we can't click on two, as we can't click on two. Okay, no problem. So let's click on histogram first. Let's see what to give us. So click on continue. Then format. We don't need anything from here. Bootstrap. Oh, zero. We don't need anything at all. So let's click on OK. So this is the output panel here. It's loading. It's loading. It's loading. It's loading. It's loading. Exactly. So now let's see it. So now the statistics we have for the age, we have for the weight, for the height. So that means that for this valid means the number of observations that are not missing. You can see that the number of observations, let's go back to our data itself. When you go to data view, what's the total number of observation we have? You can see that it is 90 that we have. It is 90. That is why it is bringing us, and that means that the valid observations that we have that are not missing is 90. Why the missing ones are 0? That means our data set is not having any missing value. So the mean for the age now, the average number for the age is now is 31.62. Then we have for the weight 76 point this, for the height as well. The median value, the mode which is 41, we have 68 and like that. So all these things now, it gives us a high knowledge or a better knowledge of what our data looks like. Now let me just say this again. Under our age now, I don't know why I just keep on calling on this age. I feel like it fits into different kind of explanations. So for our age now, we might want to change our age to be an ordinal scale. So now we have an understanding that okay, our age, the minimum is 18, the maximum is 44. Now from this minimum and maximum, we'll be able to know, okay, how do I group my data sets? Do I group it to be okay from 18 to maybe 35? No, 35 is far. Let's say 18 to 25, 26 to another one till you get to 44. So this one now is to be able to give you a better understanding of how to now group this data. For the weight, we also have 54.5. For the height, we have 1.50. So all these things gives us, interpretation of this is what my data looks like, and this is what I can do with my data set. Having all this all these little informations. Now under the age, let's continue with the outputs. Under the age, so these are the ages that we have in total. Now you can see that we have 18, then we have 44. Then the frequency, so the number of people that fall into the ages of 18 is 2. Number of 20, the frequency in under 20 is 3. Now the percent for 18 is 2.2%. That's so it's the same thing for what's the name, valid, percent, and cumulative. But under the cumulative is like it's like you adding the first and the first percent and the next one. By the time you do, is that it? No, sorry. I think that's wrong. But most importantly, I want us to know that cumulative percent is not necessary when we are running our analysis. So we also have the weight as well, the same thing. We also have the height. Now for our histogram, yes, this is it. So under the histogram, all these things are this color, all these things, all these bars, they are referred to as bins. So they are divided into this number of bins. So let's count the bins here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 bins to represent our histogram. Now the mean of this histogram is 31.62. The standard deviation is this, while the total number is 90. So now from this histogram, you can see the highest number of people that fall into this particular group. So if it is like in programming languages like R, maybe R or Python, you can give your this thing, you can give your code or the line of code. Okay, this number of bins I want, it can bring us 5 bins for us. So to better understand this, now you can see that we don't even know what number is there, what particular age falls into this line. So we also have the weight as well. Then we also have the height. So now let's go back to this descriptive. Then let's check the descriptives itself. So let's cancel this. So don't let us save. No, we are not saving. So let's go back to this. So now we have analyze and let's go back to descriptives. Now the descriptives itself. So now we have age. You can send in our ages here. You can send in our heights. You can send in parity. So to pick maybe everything, you just click on shift, then your control, I said control, the shift, and that's arrow that goes down. Yes, So just click on it, then everything will enter here. So the options that we need. So we need the mean, we need the standard deviation. So by default, it has picked all these four. So let's go with this. So we click on continue. So we have okay. So this is it. So the descriptive statistics. So this can say is just one this thing that is bringing for not like the frequency on. So under the age, the minimum is 18, the maximum is 44. Under the parity, the minimum is 0 and 9, the mean and standard deviation. So that's what descriptive statistics bring us. Now let's go back to our slide. So from the sub menu, select the type of descriptive statistics you want. We've done this one. Then a new window will open. Okay, that's that. So I want to take us to, okay, I think we are done with our slide already. So let's just basically run down our analysis itself. So now let's talk about the crosstab. So now we have groups. We have group A and we have group A and B. Then we also have marriage status, we have occupation. Now the group that we're having, it is categorical. Marital status is categorical. Occupation is categorical. Education is categorical, and menstrual cycle is also categorical. So now we want to see the relationship between all this now. So let's now check between how many number of people, how many number of married people we have under group B or group A. What's the number of people that are in occupation, that are students, that are under group B. So like that. So let's see the relationship that we have. So you go to descriptive statistics. Sorry, you go to CROSSTABs. Now, so earlier said we want our row to be group. We want marital status. So let's click on shift and that arrow down. Marital status, occupation, education, and menstrual cycle to be as our column. That's that. So let's check whether we need anything here. No, we don't need anything. Statistics, do we need anything? Let's check correlation. Let's see the relationship, if it is a positive relationship or it's a negative relationship. So you click on continue. For sales, do you need anything? No. For formats, no, not necessary. So let's click on OK. Okay. So now case summary. Okay. The group, the relationship between group and the marital status. Now that means that under group A, we have 39 people that are married. And under that same group A, we are having 4 people that are single. Under the group B, we are having 39 people that are also married. And under group B as well, we have 8 people that are married. So in total, that means the number of married that we are having is 78. That of single is 12. And by the time you add the 78 and 12, it will give us 90. By the time you add 39 and 4, add 39 and 8, it will still give us 90, which is the total number of observations that we have. We also have group and occupation. The number of people that are civil servants under group A are 9. That of HW are 16. Students 6. Traditional 12. So all this gives us this CROSSTAB gives us the relationship and the number of people that are under each categories now. So we also have that of group and education and menstrual cycle. So that is that. Okay, it's saying correlation statistics are available for numeric data only, which is true. We can't be having correlation for categorical variables. So let's see if we can have, let's just explore. It's not bad if you explore. So let's just see if we can have, let's send them back. So let's check for parity and for this one again. I want parity. Okay, let's check parity, then height. No, I think no. Let's do for height and sorry. Height and weight. Let's see if it actually give us what we need. So let's click on, now we click on the correlation. Continue. Let's whether it will give us what we want. Let's see. Okay. So this is what it is bringing out. Now you can see how long is this is. Like I don't even know how to explain this one. I don't know how to explain. It's still saying the same thing. So basically, when you are dealing with CROSSTABs, make sure your two variables are categorical. Now you can see now we're having a continuous variable and we don't even understand what we are doing here. How did we get here? But in a nutshell, people that fall into 54.5 under group A is 0, that of group B are 1. But still it doesn't make sense. So that's more reason why we use categorical variables for our CROSSTAB. So now I would like to take us back to something else. No. So under the variable view, let's see if we can classify our age years. So I don't think it's necessary. I don't think it's necessary. The next instructor will be the one to do that one. Okay, so I think that's that for under the descriptive. So let's check on graphs too. So other ways we can get our this thing is okay, we are done with that. Okay. Other ways we can get our graphs is when you go to graph itself, you go to chart builder, you click on okay, chart builder. So let's just do one. We want the line, the bar chart itself. So we drag it to this main place. Now I want us to remember that our y-axis, let's go back to our slide so that we won't be lost, where we have the graphical representation. Okay, very good. So now our x-axis represents the categories, the y-axis represents the frequency or proportion of observation in each category. So that tells us that x-axis should be what category. So what can we use as our okay? Oh, very good. We have the group. So you can drag your group here. Now the count. What do we need under the count? What do we need under the count? Okay, we can take this weights. Let's see if it will actually give us what we want. So we can go for okay. Oh, very nice. So now this is what we have here. We have the group A and the group B. But this one now, these are the frequencies. You can see that this place is the frequency, which is continuous, while the x-axis here, the horizontal line, is the what's the name, is a categorical variable. So I'll be stopping here for today because of our time. I don't know, I'm very sure most of us today was very hectic for us. So I'll be stopping here today. So next, I mean tomorrow we'll continue from where we stop. So over to you, Mr. Osho.
Thank you
Yeah,
very, very much.
yes, sir. Thank you, sir.
Thank you very
Please,
much. That was a very,
yes. Thank you.
very highlighting presentation. Really, really appreciate. Um,
Thank you, sir.
we also our instructor Oluchi piece. Um, I believe that if all of us are following, we'll be able to grab one or two things and probably be able to use it in our next um, practice or our next project. Please do ensure that you practice this. Don't just go home and wait for the next presentation. Although we'll continue from here tomorrow at the same time, just find a way to try it out. So